Hello students, I am Sachin Prakash and I teach and mentor students in chemistry for IIT. I believe that the real confidence which is required to crack this IIT exam will come only when you are confident in tackling good problems. And that clarity and understanding of concepts will only develop when you are really comfortable in handling these problems. So this video contains the paper discussion which I have conducted in my uh, classes online. Okay, and a lot of good doubts are there which I have discussed here. It will be helping you people in understanding, developing an understanding in how to approach and tackle good problems. Okay, and if you like this, if you found this paper discussion video to be useful and interesting, you can, like, comment, and subscribe to this channel, which will surely, motivate me to add some more useful videos of this type. Okay, because ultimately it's this is just an effort, honest effort, small honest effort from my side to help the student, uh, help my students as well as other students also in their ITJ preparation. So let us begin with this paper discussion. Okay.
Starting the paper discussion now. There's no point of waiting. Okay, so welcome people. Today we are going to discuss WTM 23, which is based on solid state. Okay, so this is based on the new JMS pattern 2021, which is consisting of 20 questions of single correct type and 10 questions are from numerical value, out of which you are only supposed to attempt 5 of them. Okay, so let us start our discussion. Question number 31 to 36. Yes. Any doubts?
No, sir.
No, sir.
No. Then 37, 38.
No, sir.
No. Then
So once can you explain 37?
yeah, definitely. I was hoping. Okay. So 37 is basically based on the density equation which I have discussed in the class. What is the density equation? Can you tell me?
Z into
Yeah, that is rho is equal to Z into
Molecular weight.
M by molecular weight by
Avogadro's number
into
to
okay.
Avogadro number.
Yes. Okay. Just 1 minute. Now, this is a formula in which the units are important. This is in gram per cc. Okay, then this should be in centimeter and this should be in grams, right? Okay, now you see if Z is 1, then it is simple cubic. Z is 2, it is BCC. If Z is 4, it is FCC, effective number of atoms, right? So if I know the value of Z, I can predict what type of structure it is residing in.
Yes, sir.
Yes or no?
Yes,
Okay.
sir. Yes.
That is the core idea behind this question. The rest of the things is now, well, you see, if I'm talking about 0.136 nanometer, 0.136 nanometer is basically 1.36 angstroms. There is 1.36 into 10 to the power minus 8 centimeter, right?
Yes, sir.
Okay. So I can write 19.4 is equal to Z is something which I want to find out. MW is 184 by Na is 6 into 10 to the power 23 into 1.36. It's very beneficial if you always convert it into angstroms, because then when you convert angstroms into centimeter, you'll get 10 to the power minus 8 centimeter. Are you getting a point? Now
Yes.
then when you do the cube, then it will be like 10 to the power minus 24 which will cancel out 10 power 23 easily.
Yes.
Are you getting a point? So then your calculation will become a bit simple. Okay, so this will go like 10 power minus 1, okay, which will go up, so it will be like z into 1840, okay, by 6 into 1.36 whole cube. So from this I can get the value of z. It is 19.4 into 6 into 1.36 whole cube. Now 1.36 whole cube, what will be this value?
2.5
1.36,
answer.
2.515. Okay, so I can take it to 2.5 also. Okay, by 1840, right? Okay,
Yes,
so
sir.
basically it will be something like, see, 2.5 into 6 will be like 15, okay, and 15, 1 is 15, okay, and 15, 1 is 15, am I doing something wrong? No. 15 on the 15, 24, 34, 52 is 30. It's like 123 times. Okay, so that should be, okay, there's something which we are missing in this.
That is 184.
Huh?
So, 0.136 is like the radius of the atom, right?
Yes, sir.
But in
But their
formula,
A is
A
not
cube we use
radius
Yeah,
for
into it.
volume.
yes. We have to first find the value of A, right?
Yes,
Okay,
sir.
so the best thing is that don't use this value. Okay. I didn't look into that part. Okay, let me just. Okay, so let us write it as z by a cube. Okay, so from this I can get the value of z by a cube as what? It will be like 19.4 into 6 into 123. Okay, now, okay, so it is given that what type of crystal structure it will be in. So we'll be having like now depending on the value of z and a. Okay.
Without knowing the type of structure, how can we get a relation between radius and side?
Yes, that is the thing. So okay, let us try. Okay, what's there in not trying? 19.4 into 6 into 10 power 23 by 184. Okay, so let me just try this. 19.4 into 6 divided by 184. That's like 0.632 into 10 power 23. Okay, or so 0.632 into 10 power 23 or 63.2 into 10 power 21. Okay, that is equal to z by a cube. Now you see, a is a function of r, yes or no?
Yes, sir.
Yes, sir.
Okay, now so uh, so so a is equal to like 2r when it is simple cubic, right?
Yes, sir.
Okay, so and a is equal to 2 root 2r for FCC, right? Something like this. And a is equal to 4 by root 3 r for BCC. Is it like this?
Yes, sir.
So I can write a general expression that A is equal to KF, where K is something which is changing. Yes or no?
Yes, sir.
Okay. So if I'm writing A as KR, then I can write Z by A cube as what? Z by K cube into R cube. Yes or no? This is 63 1 to 10 power 21. So if I'm writing Z by K cube, okay. See, I am also trying to do something in this. Okay. 63.2 into 10 power 21 into R value. What is the value of R? It is supposed to be written in centimeters. It's like 1.36 whole cube into 10 to the power minus 24. Okay. Or it was written as 0.632, no? Write it like this only. Okay. So this is like 10 to the power minus 1. Okay. And this value is like 2.515, right?
Yes, sir.
Okay. So 0.632 into 2.515. It's like 1.59. Okay. Or 1.59. Okay. Into 10 to the power minus 1. Or 0.159 or 0.16 approximately. Yes or no?
Yes,
Yes,
sir.
sir.
Okay. Now see Z by K cube. Now you see the value for simple cubic the value of K is 2. For this it is K by 2.83, and for BCC it is K is equal to how much?
2.
4 divided by 1.732.
2.3.
2.3. Okay. So we have to find the Z by K cube for each of them. There is no other way out. Are you getting a point? So for simple cubic, what is the value of Z by K cube?
1 by 8.
1 by 8. So it is like 0.125. Okay. For BCC, Z is how much? Z by K cube is 2 by 2.3 whole cube. Okay. So if you are writing 2.3 whole cube, okay, then inverse into 2, we will get this value to be 0.164. Okay, so this is the closest value. If you do for FCC, then Z by KQ will be how much? It will be 1 by 4 by 2.83. 4 by 2 root 2 whole cube. It's like 4 by 6, 8 into 2 root 2, 16 root 2. So it's like 1 by 4 root 2. Okay. So it is basically 4 into 1.414 and then inverse. So that is 0.176. So Z by KQ is most closest to BCC, so the answer should be BCC. Is it clear? Yes or no? There's no other way of doing this question.
Yes, sir.
Okay. What have they given in the class in the answers? Let me check. Have they written conceptual? No.
Just formula there is.
Yeah. That too they have not given. Zm by NAQ. Okay. But anyways, you got how to do this question?
Yes,
Yes.
sir.
Okay. So you see, you can also write these things in theory, this part. Okay. That if A is function of A is written as K of R, then what will be the values of Z by A cube? Are you getting it? This part you can write in the theory. Is it clear? And then you can use it in the formula. Then, okay. So see, you are having two variables and you have only one equation. So that is why you have to check. Are you getting a point? Which value is lying in the range?
Yes, sir.
Okay? Yeah. So this is good. How you people have done it like this only?
Yes, sir.
Okay. That's good. So 38 is not a doubt. I think it is like the spinal type
Yes,
of,
sir.
Similar question.
yeah. 39, 40,
No
41,
doubts.
42, 43. There's a lot of questions are from density equation. I have told you before. That is the only formula in the whole chapter. So you are
Yes,
bound to get a question from this. 42, 43, no doubts?
No, sir.
That's very good. Then 44, 45, 46.
No, sir.
No doubt, sir.
That's very good. 47, 48, 49.
No, sir.
No, sir.
That's good.
Sir, can you explain 47?
Yeah, I can explain 47. See, KCS crystallizes in the same lattice as NaCl, given R of Na plus by R of Cl minus. Okay. So ratio side of unit cell of K plus to the side of Na plus. Okay. So you see, since NaCl and KCl both have same type of structure, they will have the same relationship between A and R. A will be what? 2 into R plus R of cation plus R of anion. Yes or no? For
Yes.
NaCl, it will be what? A1 is equal to 2 into R of Na plus R of Cl minus, and A2 will be what? For KCl, it will be 2 of, okay, they are asking KCl to NaCl. No, okay, A2 by A1. So R of K plus R of Cl minus. So I can write A2 by A1. This is what I want to find. 2 will cancel out. So it is basically R of K plus R of Cl minus by R of Na plus R of Cl minus. Yes or no?
Yes.
Now, you see, if you take R of Cl minus common, then it will be basically R of Cl minus into R of K plus by R of Cl minus plus 1 by R of Cl minus R of Na plus by R of Cl minus plus 1. Is it clear? This will
Yes.
cancel out.
Yes,
Now,
sir.
basically, now you are knowing R of Na plus by R of Cl minus, you know, it is how much? 0.5 plus 1. R of K plus by R of Cl minus, you don't know. But you know two of the ratios. You can find the third one. So, R of K plus by R of Cl minus can be written R of K plus by R of Na plus, okay, into R of Na plus by R of Cl minus. So R of K plus by Na plus will be what? 1 by 0.7 into R of Na plus by Cl minus is 0.5. It's 0.5 by, it is basically 5 by 7 plus 1. Yes or no? So
Yes.
it's like 12 by 7,
Well,
1.5. It is like 8 by 7. So it's 1.143. Is it clear?
Yes,
yes,
sir.
sir.
That's very good. Okay. Apart from this, 48, 49 is easy. 50.
Sir, can you say 48th one?
48. How many unit cells are present in 5 grams? Okay, so I have discussed this point in the class that if you have an NaCl type of structure, then effective number of formula Z will be 4, means you'll have 4 Na plus,
Yes, sir.
4
4
Cl
cell
minus.
minus.
So you have 4 units of AB in 1 unit cell. Yes or no?
Yes, sir.
Okay, so you have in 4 moles. So in 1 mole of unit cells, how much you will have?
1/4.
You'll have 4 into 40 grams of AB, because 1 mole of AB is 40, so 4 moles, 1 mole of unit cells will contain 4 mole of formula units of AB. It's 160. So now 160 gram is in 1 mole of unit cell or Na unit cell. So in
5 grams.
5 grams you'll have 1/32 moles. Is it clear?
Yes, sir.
Yes, sir.
Okay.
Yes.
Okay. 50 is not a doubt. I think 50 is type of question we have discussed in the class.
Yes, sir.
Okay. So then this leads to 51 to 56. (51 to 56).
60, sir.
56.
60, sir.
Correct. 60. Before 60 there is no doubt.
No, sir.
Okay. Now you see, I have given you a simple concept that if in any type of crystal system, number of atoms in a unit cell is n, the number of tetrahedral voids will be 2n. Yes or no? Have I told this?
Yes, sir.
Okay. So in
Yes,
FCC,
sir.
if the effective number of atoms is 4, then what is the number of tetrahedral voids? 8. The number of
Yes, sir.
octahedral voids? 4. Okay. For SCP unit cell, number of atoms is 6. So number of tetrahedral voids is 12. Number of octahedral voids is 6.
6.
Okay. Now I have told you that ABC type of pattern is for what? CCP or FCC? Yes or no?
Yes.
Okay. Now, so you see, so you have 4 atoms in a unit cell effectively, and for that you have 8 tetrahedral voids. Yes or no?
Yes, sir.
So for 4 atoms, if you have 8 tetrahedral voids, so for 4 mole of atom, you have 8 mole of tetrahedral voids.
Yes, sir.
Okay? Yes or no? So for 3
Yes,
mole
sir.
of atom, you have what?
6.
6 mole of tetrahedral voids. Is it clear? Yes or no?
Yes, sir. Yes, sir.
Okay. Other questions are okay?
54, sir.
54.
Okay, not needed, sir.
Not required?
No, sir.
Okay. So again here E is given and the density is given. So you have to find Z.
Yes, sir.
Okay.
Yes, sir.
Okay. In cubic system, how many atoms arrangement exists? So it's 3. These things are easy. So I think we have discussed everything which is there. In from his point of view, our coverage was good, right? So let us look into the advanced part. Is it good? Yes or no?
Yes, sir.
Okay. So with this,
So,
you have
once can
any
you explain 49th?
Yeah, definitely. So you see in 49, you basically have NaCl type of structure. So NaCl type of structure means what? You have FCC
FCC or
of
CCP.
of Cl minus and Na. So you see the density is given for NaCl Z is 4. Yes or no? Because it's a FCC network, you have 4
Yeah.
minus a 4 Na plus also.
Yes,
So
sir.
if you are writing rho, rho is Z into MW by Na cube. Rho is how much? It's 8.27. Z is 4 into MW. Now you have to write for cadmium oxide, right?
Yes.
Now for cadmium, they have not given the molar mass, right?
Yes,
I
sir.
think for cadmium it is like cadmium molar mass is like 56.
128, I think, sir.
No, yeah, they have not given this, no? It's 112 cadmium. Okay,
Yes, sir.
that they should have given. Have they given it anywhere in this paper? No.
No, sir.
Okay, so without that it is difficult to do actually. So 112 plus 16 for oxygen by Na is how much? Na is 6 into
Sir
10.
will get 128 only.
Yeah, that I know. Okay, AQ. So I can find the value of AQ. 4 into 128 by 8.27 into 6. Okay, into 10 power minus 23. So if we do the calculations, I think you are at home, so you can look into the mass.
Yes, sir. Okay.
Okay, so but in ITJ they will give it. Okay, don't worry. So it's like 10.318. It is like 10.32 into 10 power minus 23. I can write it as 103.2 into 10 to the power minus 24 centimeter cube. Okay, so A value will be how much? Cube root of this value. So shift cube root 103.2. It's like 10.16 into 10 power minus 8 centimeter. Okay, or 10 power minus 10.16 angstroms. Okay, now you see, if it is a rock salt structure, then A is what? 2 into R of cadmium 2 plus R of oxide of minus. Okay, so 10.16 is basically 2 into R of cadmium 2 plus 1.24
1.24.
is like 5 point, how much it is? 5.58, right? So R of
Yes.
cadmium 2 plus will be
5.08.
Yeah.
5.08. So yeah, okay. So it's like 5.08 minus 1.24. So it should come out with 3.84. Are you people getting this value? Have you done the
Yes.
calculation correct? Have they written conceptual again for this? A is coming out to be 46.8. Have we made some mistake at any point?
So I think you took the square root of 103.2.
Square root, cube root, okay, 1 minute. shift to 3.2. Yeah. It's like 4.7. Okay. So
Yes, sir.
4.69.
We should
Okay,
get
yeah.
some 4.68 like that.
Yeah, so therefore it's like 4.69 angstroms. Okay, so yeah, 4.68 you are saying, no? Take it 4.68,
Yes,
it will
sir.
cancel out. So there is a 2.34. So R will be 1.1. Yeah,
1.1.
these things are calculation based only. Other than that, so is it clear? Process is that,
Yes.
but the only thing in this question is calculation. Nothing else is there. Is it clear?
Yes, sir.
Okay. Other than that,
Sir,
yeah,
sir,
tell me.
sir, I joined very late because of some technical issue. Like,
Yeah.
can you just tell me if you discuss those questions or not? Like 37th?
Okay, just 1 minute. 1 minute. Hello. Okay,
Can you just tell me the method? I was not getting these density problems correctly.
okay. So 42, it is something like in 42, the question is atomic solid crystallizes as BCC, and if the atoms at adjacent corner are separated by 60.3 picometers. Adjacent corners means like this, yes or no?
Yes, sir.
So A is what? 60.3 picometers.
Sir, their body-centered cubic lattice and the inner surface, you said, like, what does it mean?
1 minute. No, see, atomic solid is crystallizing as BCC. Means the lattice unit cell is BCC.
Sir,
And the inner surface.
Sir, what is that 60.3?
It is basically telling you A.
there is some distance between.
That
That
is not the
Get the
distance between
question right.
centers, no, sir.
yeah.
No.
We should take A equals 2R plus 60.3.
Yes, sir.
A will be 60.3. Okay.
Yes, sir.
So if rho is what? Rho is Z into Z is 2 into MW is 48 by Na 6 into 10 power 23 into AQ will be basically for 60.3 picometers is 0.6 angstroms.
So 60.3 plus 2R, right?
Yeah, sir.
Uh, adjacent corners are separated by, okay, you are saying that is something like this. This is
Yes,
60.
sir.
Yes, sir.
So we will take total A if we take.
But then the problem is that
Sir, what does he mean by inner surface?
Yes, sir. Like, does he mean it's also present at the centers along BCC or, I mean, face centers or what, sir?
I think then this inner surface part is extra.
Which is body center, no, sir.
The body center means that you have a simple cubic system in which you have a extra atom at body center. Okay.
Yeah, yes.
Now, atoms at the adjacent corner. So a corner means you are talking about corner lattice points only, no? So that means you're talking about A only. Getting a point.
Yes, sir.
So if you are doing something like this, then it will be like 2 into 480 to 6 into points whole cube. But that will mean a very high density,
Sir,
right?
if he, sir, maybe
Yeah,
he
sir.
means like the distance between the surfaces of the atoms at adjacent corners. Then we'll take 2r plus 60.3, right?
See, you cannot, you have only one equation. Are you getting a point? And you need to find density as, so if R is not given, how will you find the density? Are you
Yes,
getting a
sir.
point? So, if you are doing something like this, 2 into 48, right?
We can cancel out, sir, R
I think
by
it's
taking the
60.3 nanometers, something like that. No, not 60.3 nanometers. 60.3 picometers will be how much? 0.6 angstroms. Mm, so it's like 0.6 plus 80 plus 60 by 0.6 whole cube. No, this value is too high.
yeah, sir, will not get in that way.
Mm, what have they proposed in the question? So,
So, so we know the relation between radius and A, right?
Yeah, sir. When we substitute in that,
When we substitute the relation in
yeah.
the 60.2 in plus 2r, we get the answers.
okay. You are saying something like that. Okay.
Yes, sir.
So you say that since it is BCC, A is like root 3, 4 by root
Yeah,
3.
you. Yes,
Yes,
sir.
sir.
Okay. So basically this distance is given. This is something which you need to find out. This is A, right?
Yes,
Okay.
sir.
But so basically A is equal to uh,
2R plus
2R plus
60.3.
60.3. Yeah. Okay. Yes. So 4 by root 3R is how much? Can you tell me? I think we calculated it right now.
Sir, we can substitute 2r equals root 3a by 2, we get a directly.
Yeah. Okay. Yeah, you can do that also. But okay. You are saying that you are using it as root 3, no?
Yes, sir.
Okay. So 2R is A by root 3. So again, then you have to find A by root 3. So square root of 3 is this.
Sir, it is root
Root
3a by
3a by
2.
2.
Hmm, 1 minute. A is equal to R plus R. Root 3 is equal to 4R, no? So
Yes,
yeah,
sir.
2R is equal to root 3 by 2. Yeah. So if you are using root 3 by 2, then it's basically 0.866. So it's 1 minus 0.866, 0.134A is 60.3. Yeah, from this A will be 60.3 divided by 0.134. Yeah, so it is like 450 picometers or 4.5 angstroms. Yeah, then you can use it there.
Yeah, sir.
So if you use it here, it is like 4.5 whole cube into 10 power 24. So it is 96 into 10 by 6 into 4.5 whole cube and 5 shift cube root. The cube is 91.25.
125.
So it will come out something close to 1.75. Yeah.
Yes, sir.
Okay. Yeah. So here the only thing is they are talking adjacent means. Okay. So here they are missing the word at the inner surface. If the atoms at the adjacent corners are separated by 60.3 pp. Okay. This word is important here. Are you getting a point? That at the inner surface, if they are separated by this distance. Is it clear?
Sir, but it's hard to understand, right? Like
Yeah, it is hard to
get
understand.
that A minus 2R part.
Yeah, the wordings are important in these type of questions. But everyone is getting this? Yes or no?
Yes, sir.
Okay, 43. What? Again, interfacial separation between the atoms at the edge is 53.6. So again, they are taking the same thing here. And if interfacial separation they are talking about, again, these are the two atoms. Okay, this difference is 53.6 and this is A. Getting a point? So basically again A is what? Root 3A by 2 plus 53.6. So 0.134A is equal to 53.6. So A is how much? A is 53.6 divided by 0.134. So it's like 400 picometers or 4 angstroms. So density will be equal to what? Z is 2 into MW is 23 by 6 into 10 to the power 23
404
into 4 cube 64 into 10 to the power minus 24. Okay, it's like 460 by 6 into 64. Are you getting a point? So 460 divided by 6 into 64. This is 1.2, 197. Is it clear?
Yes,
42
sir.
or 43 both are similar type of questions. Only thing is this word is more clear than at the inner surface. Are you getting a point?
Yes, sir. Okay.
Other than that, any other doubts in this paper?
Can you explain 39, please?
33,
39, sir.
39. Yeah. Coordination numbers of point A and B. Okay. Coordination number of point A and point B. Now you see A. Okay. So this is like an FCC unit cell or NaCl type of structure. So this is the chloride ion. Yes or no?
Yes.
Now the nearest is at a distance of A by 2. Yes or no?
Yes, sir.
B. Okay. So for that you have to move A by 2 along one of the axes. So A will have a coordination number of 6. Yes or no?
Yes.
And since it is 6 by 6, one NaCl is the formula. So Na plus will also have 6. So B will also have 6.
Yeah.
You have to identify which structure it is representing. Is it clear?
Yes, sir.
They will ask questions only from the parts which we have discussed in the class. Are you getting a point?
Yes,
Only thing
sir.
is you have to identify the pattern. Okay? Any other doubts in this paper?
Sir, but
No, sir.
The body center is not occupied, no, sir.
Yeah, body center is not occupied. It's okay. But still, if you are looking at this atom, okay, as reference, what is the nearest atom? It is at a distance of a/2 only along one of the axes.
Yes, sir.
So using that logic, also the answer will be 6 only.
Okay,
Are
sir.
you getting a point?
Yes, sir.
Okay. So I guess any other doubt in this paper?
No, sir.
No, sir. No, sir.
Okay. So if there is no doubt, then we can conclude this paper discussion.
Yes, sir.
Okay. So I think you'll get this similar type of paper tomorrow also. Okay. So attempt the paper confidently. Okay. Now you see solid state is almost finished. Okay. Let me just. So the paper discussion is officially over. I'm stopping. Okay. So now we are live, and today we are going to discuss WTA 23, which is basically based on solid state. It's an advanced paper. So it is consisting of 3 sections. Okay, section 1 is integer type, and then you have section 2, which is matrix. Section 2 is like multi-correct. Okay, and then you have section 3, which is match the columns. Okay, so there are like 20 questions in this paper. Okay, and mostly they are either single integer or multi-correct. Okay, so let us start with question number 21 to 25. If you are having any doubts. 21 is a
No,
doubt?
sir.
It is a doubt.
No, no.
No, that's good. 21 is basically HCP if you minus unit cell minus the middle layer. Okay. In that
Yeah.
case, basically you are having 12 corner atoms and 2 face center atoms. It will be 3. Okay. 21 to 25, no doubts. I think that is most of the questions are straightforward.
Yes, sir.
Okay. So 25, 26.
26.
Yeah.
26.
Okay. So I think you saw the solution and you feel like that is a different approach, right? One approach is of doing this is the way which we discussed yesterday. Did you see the yesterday's means paper? There was a question where we were using A is equal to KR and doing that using the density equation, right? Yes or no?
Yes, sir.
Yes, sir.
Now see, density equation is also based on tiling fraction only. Is it clear? So I will just discuss that question, you see. I will do it, okay, so in front of you, so it will be easier. So you see, what is there is that your density is given. So you see, what is packing fraction? It's basically volume of atoms by volume of unit cell. Yes or no?
Yes, sir.
And density is also something like that only. Density gives you mass of atoms
Volume of units.
by volume of unit cell. Now from mass you can find out number, and from number you can find out volume of atoms. Are you getting a point?
Yes.
Okay. So if that is the case, then can we find a formula for that? Can you try? Let us try. Okay. So we write rho as Z into MW by NA by AQ. Is it not like that? Yes or no?
Yes, sir.
Okay. Now you see, AQ is what? The volume of unit cell, and this is what? This whole thing is basically the mass of atoms. Yes or no?
Yes, sir.
Yes, sir.
Sir,
Okay.
NA into AQ, right?
So Na I have put an up in numerator.
Yeah, okay.
Okay. So this is basically representing a mass of the atoms. Okay. So if I put MW this side, okay. So you see, if M mass of atoms is this, then what is the number of atoms? Number of atoms will be what? So it will be basically rho by MW. Sorry. Uh, so how do we? Okay, let us. Okay, so let us see that density. What is density given? It is 1 by 135 gram in 1 cc of unit of atom. So this is basically mass of atoms, and this is the volume of unit cell. Yes or no? Now, what is this 1 by 135 gram? It is 1 by 135 into 60 moles of atoms. Yes or no? Which is what? 1 by 135 into 60 into 6 into 10 to the power 23 atoms. Yes or no? Or that is equal to what? 10 to the power 22 by 135 atoms. Yes or no? Are you getting a point? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Now, you see these many atoms are there in, what is the volume occupied by the atoms? It will be into 4 by 3 pi r cube. This is the volume of atoms. Yes or no?
Yes.
Yes, sir.
Okay. So, you see, what is the packing fraction? Packing fraction will be volume of atoms by volume of unit cell. Yes or no?
Yes.
What is the volume of atoms? It is 10 to the power 22 by 135. Volume of unit cell is 1 cc. Yes or no? And volume of unit cell is 1 cc. Volume of atoms is this much into 4 by 3 into pi, right? Into r cube. What is r? 7.5 root 3 whole cube into 10 to the power minus 24, because we have to express everything in centimeter. Yes or no?
Yes, sir.
Because
Yes,
here
sir.
it is in centimeter per cc. Okay. So if you are doing it, then the expression will be something like this. By 135 into 3 will be like 405. Okay. Into pi. Okay. Into 7.5 root 3 will be something close to 13. Are you getting a point? A 13 whole cube will be something, if you do the whole cube thing, it will come out to be something like 2192. Okay. And into 10 to the power minus 24. Now you see 10 to the power minus 24 and 10 to the power 22 will cancel out. Yes or no? So basically it will be equal to 21.92 into 4 pi is the divided of 405. Okay, so this will come out to be something like 0.68. This means if packing fraction is 0.68, means this is BCC. Yes or no?
Yes, sir.
And if that is the case, then root 3 will be equal to 4R. This means A will be 4 by root 3 into R is how much? 7.5 root 3. So it is 30 angstroms or 3 nanometers. Is it clear? Yes or no?
Yes, sir.
Okay. So that is the case here. Now, so is this clear to all of you?
Yes, sir.
Yes, sir.
Okay. So this is done. 26 is done. After that, 27, 28. I think 28 should be a doubt, right? Is it?
Yes, sir.
So 28 is something which I will discuss at the end of this class. Okay. Because there are a lot of things to be they are asking. Okay. We'll discuss it. It's not very tough. Okay. But let us first explore other questions. These are the sort of questions you actually leave first, and you do it when there is excess of time. Is it clear to all of you? Okay, so we'll discuss this at the last. Just remind me. But let us first finish other relevant questions. 29, doubt? In 29, you see, octahedral and tetrahedral voids won't touch each other. Are you getting a point? Because they are touching the lattice points.
Yes.
Is it clear? Okay.
So can you explain D in that?
D.
Yes.
Okay, radius of A atoms is 200 picometers. What is the edge length of the unit cell? Okay, so it will be 2 root 2A.
Yes, sir.
That's it. Okay. It will be 2 root 2A. So 200 picometer is 2 angstroms. So 2 root 2 is 4 root 2 angstroms. Okay. Now after this, 30 and 31.
At 30, can you explain option C and D?
Yeah. You see, I think did you people look into the video which I asked you people to do because there was no time.
Yeah.
Okay, so let me just do one thing. Okay, I'm just pausing it for yes or no. Because when you're covering the voids, only the down triangular voids or up triangular voids are completely getting covered. If down is getting covered, then up won't be getting covered completely. So B is also correct. Yes or no? When you're talking about C, tetrahedral voids are found when triangular voids in the second layer lie above the triangular voids of the first layer and the triangular shapes are not overlapping. See, if this void is getting covered with another void, okay, you see here this void is getting overlapped by the triangular void from the red layer, yes or no? I'm talking about this one. You see, let us say this, on this I am focusing. Then this triangular void of the red layer is on the top of the triangular voids of the bottom layer, yes or no?
Yes, sir.
And they are not completely overlapping, only partial overlapping is taking place.
Yes, sir.
Okay, so this is the situation for octahedral voids. Okay, so in octahedral voids, what happens is that if you are having these three layers, okay, then this triangular void is not completely covered. If I am placing the something like this triangular void is not getting covered properly. Are you getting a point? Yes or no?
Yes, sir.
So this is giving rise to what? An octahedral void. Is it clear?
Yes,
And third is that if octahedral voids are found when triangular voids of second layer exactly overlap with the similar voids of the first layer. Now you see, if I exactly put, if suppose I am having this as the bottom layer, and I am exactly putting 1, 1, and 1. Then what is happening? The triangular voids of green layer are exactly on top of triangular voids of
Red one.
red one. Yes or no?
Yes.
So in this case, what type of void will you be getting? You will be getting a some sort of not exactly cubical voids, but you will be getting something like triangular prism type of voids. Yes or no? It will be something like this. Upper layer is like this, and the lower layer is also like this. So it is like a prism. You have a triangle up, a triangle down, and connected by dots. Yes or no?
Yes, sir.
So it will be some sort of not exactly triangular cubical void. It will be triangular prism type of voids, because we are talking about like, see, you get cubical voids when you have square inner voids in 2D. Then you get cubical voids in 3D. Are you getting a point? If you translate a square along 3 dimension, you'll get a cube. Getting a point? So if you translate a triangle over 3D, you'll get a triangular prism. Yes or no?
Yes, sir.
Okay, so you want it, so you will get triangular prism type of void. Are you getting a point? Yes or no? So C and
Yes,
D
sir.
both are wrong. Everyone is clear? Yes, no?
Yes, sir.
Okay.
Yes, sir.
Okay. So after this 31, 32. I have told you that halides will be, most of the ionic halides will be having rock salt structure, except of for the cesium and thallium halides, right?
Yes, sir.
Yes.
Sir,
Yes.
sir, you got RNA plus by subtracting that RF minus from that internal
Yeah,
ionic
obviously
distance.
this is BCA.
Sir, like, okay. Sir, like both of them won't touch each other, right?
See, cations and anions will touch each other, not for a stable acid. Anion and anions won't touch each other for stability.
Oh, yeah, okay, sir. I thought, yeah, okay, sir. I thought he was considering along it.
Yeah,
Yes,
that
sir.
is what. Okay. 31 is clear to all of you, yes or no?
Yes.
Okay. 32? What about 32?
No, no, sir.
No doubt.
Okay, this is easy only, you have to just check. Okay,
Yeah.
I think it is ABC if you're talking about the formula or the ionic compound, right? 33 to 37.
Sir, 36.
Okay, zinc blend is basically a sphalerite structure. Are you getting a
36.
point? 36. Okay. An element exists in two allotropic forms that I have discussed in the class also. That as if zinc sulfide exists in both SCP and CCP, the packing fraction is same, so the density, volume density will be same. The coordination number will also be same. For SCP also, the coordination number is 12 only, right?
Yes.
And then fraction of unoccupied space with void fraction will be same. Distance between two consecutive layers will also be same only. Are you getting a point?
Yes, sir.
Okay. So 36 is done. 37, 38. 37, you have to just see which one is the correct. All others will be incorrect. So I think this is easy. Only A is satisfying MX3. Yes or no? 37, 38, any doubts?
38.
38. AB is having a rock salt structure. Cation radius is 200. So you see rock salt structure, what is the range for rock salt structure? Rock salt structure means that the radius ratio should be lying between 0.414, sorry,
0.732.
0.732 and 0.414. So
Yes.
radius of cation is given to be, well, radius of anion is 0.414. So radius of anion will be what? It will be 200 by 0.414. This will be the limits radius of anion 0.732. Radius of anion 200 by 0.732. These are the limits of the anion sizes for rock salt structure, yes or no? So if we calculate the stuff,
483, so some around
it is 483
273 another.
and 273 another. So it should lie between these two, so answer should be A and B only. Or you can also calculate the radius ratio, it is easier. 200 by 400.5 lies, 200 by 10.67 lies, 200 by 201, obviously cubical voids, 200 by 500.4, obviously tetrahedral void. Is it clear? And do it that way also. Is it clear? Yes or no?
WTM would not come.
Huh? What are you people saying? Can you repeat? Is there any doubt in this? See, rock salt type structure means one atom is in lattice point, CCP, another is in octahedral void. This is rock salt type structure. Is it clear?
Yes, sir.
Okay, everyone is clear with this? 38? Can you move?
Yes, sir.
Okay. So 39, 40? 39 should not be a doubt. 40, there are some extra options.
Yes, sir.
Okay, like zinc sulfide. They have not mentioned which zinc sulfide. Zinc sulfide is having both FCC and SCP structures.
Yes.
So answer should be PQRS. Okay. Answer should be PQRS. So you see, if your particles are lying in tetrahedral voids, then the closest distance would be root 3 by 4a. If they are lying in octahedral voids, the closest distance between the cation and anion will be a by 2. Is it clear? Distance closest between particles is basically the cation and anion distance. Getting a point? Yes or no? So in zinc sulfide, your zinc 2 plus ion is in what? Tetrahedral voids. So root 3 by 4a. So QRS and P is also correct because there is another structure which is Woodside structure of zinc sulfide. Is it clear? Which is SCP. So even P, okay, they have not given P actually. QRS they have given. So P is also correct. The sphalerite structure is FCC only. Is it clear? Yes or no? Okay, CaF2. Again, it is having FCC of calcium 2 plus ions. And obviously R will be there because it is having tetrahedral voids. And only one type of voids is occupied, that is also correct. So P, R and S. Okay? So you see between R and T only one will be there. If R is there, T won't be there. Okay, S is there in all cases. NaCl will be having S, which is only S is given, but P is also correct. It is FCC, and T is also correct. Distance between the closest particles, which is DCA A by 2. And diamond is having what?
Sir?
Yeah.
Sir, okay, sir, nothing continue.
Huh? Can you repeat? The voice is cutting off.
Sir, in A, like between T and R.
T and R. See, in A, zinc sulfide, whether it is SCP or a CCP, the smaller particle which is zinc 2 plus is always occupying tetrahedral voids. So only one type of voids. Type means what? Either tetrahedral or octahedral? Yes or no?
Yes, sir, like T and R, then that closest distance.
Yeah. So if your particle is residing in a tetrahedral void, then the distance between cation and anion will be root 3 by 4a. Because cation and anions are touching each other.
Yes, sir.
Okay. If it is an octahedral void, it will be a by 2. Because again, octahedral void is along the edge length and at the edge center. So
Yes, sir.
these are the only two conditions. Getting your point?
Yes, sir. Okay.
If it is cubical voids, then what will be DCA? It will be along the body diagonal. So DCA will be what? It will be root 3a by 2. Yes or no?
Yes, sir.
Okay. So diamond crystal, it will be R is given because it is in tetrahedral void. So P is also correct because it is FCC, and S is also correct because only tetrahedral voids are occupied. Is it clear? Yes or no?
Yes, sir.
So this will be the only key changes which is there. Other than that, I don't think there is any other key change in this work. So this brings us to the last question, which is question number 28, right? Yes or no?
Yes, sir.
Okay, now you see, I will be doing it one by one. First, we will write tetrahedron, then octahedron, and then cube. Okay, so let us start with tetrahedron. Okay, now you see, truncated solids is something which can be taught, but there is not enough time, and it is not a core concept. Okay, so I am just drawing it. Okay, so how do you draw a tetrahedron? You draw it like this, and there is an apex, and you join the apex with, some other.
Three corner.
Yes or no?
Yes, sir.
Okay. Now you see, if I'm taking a knife and I'm cutting one of the apex, then I will cut it like this. Yes or no?
Yes, sir.
See, when you're cutting it from the top, the cross section will be mirroring the type which is with the base. Yes or no?
Yes, sir.
If
Triangle.
the base is triangular, the cross section of the cut part will be a triangle only. Yes or no?
Yes, sir.
What is happening? What is the number of triangular faces in the tetrahedron? Now, if you are cutting out one vertex, you are getting one triangular face.
Yes.
Cross section. Okay. Now, if I do it here also, one minute. Let me just try it again. Okay, so if I am taking it and I am cutting it like this, I am taking it, I am cutting it like this, I am taking it. Okay, I have cut it like this. Yes or no? So you see, now if I am talking about number of faces, you see, if you have cut this, what is the rest part of the truncated solid? It is consisting of this area. Okay, this, 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 and this, and this. Sorry. Yes or no? This is one of the face. Earlier it was a. See, if you are seeing across a face, okay. If you are seeing, 1 minute. If you are seeing across a face, this is initial face. Okay, now you took a cut here, here, and here. Yes or no? Truncation means this only, no? So now what is left? It is something like this. what is this? This is hexagonal phase. Are you getting a point?
Yes, sir.
If you are cutting a triangle, okay, this is something which you have to understand. Okay, if you are cutting a triangle like this, then what you are getting a hexagonal face left. Okay, so this is the number of hexagons they are talking about. Now, how many faces in a what do you say, tetrahedron? 4.
Yeah.
Yes,
The
sir.
number of hexagons will be 4 also only.
Yes,
Okay.
sir.
Yes, sir.
In tetrahedron, the truncated face is what?
4.
Truncated face is hexagon. So number of truncated faces will be equal to number of original faces in hexagon. Yes or no?
Yes, sir.
Okay. So you can always write that number of truncated faces is equal to number of original faces. This is the first thing. And number of truncated vertex is equal to number of truncated vertex, number of truncated cross sections. Okay. Is equal to number of vertexes original. Yes or no? See, if I am cutting this, I am getting this cross section which I have shaded. Yes or no? Similarly, I will get a cross section here also. I will get a cross section here also. Is it clear? Yes or no?
Yes, sir.
Okay. So you see, in case of tetrahedron, the hexagon, the truncated face is hexagon. So number of hexagons will be 4 because that is the original number of faces. Yes or no? And number of now truncated vertex. What is the truncated vertex in this case? It's triangle. So how many triangles will be there? It will be equal to number of vertexes only. So again, it will be 4. Yes or no?
Yes, sir.
Okay. Now you see, third thing they are asking is the number of corners. Now you see, when you are truncating, then one vertex is replaced by 3 corners. Yes or no?
Yes, sir.
Okay. So number of truncated vertexes will be what? Is equal to number of original vertex. See, these are not formula. I'm just giving you into the cross-sectional vertices of cross-section. Yes or no? So what is the number of vertices in cross-section? 3. Yes or no? So for each vertex which I am cutting off, I will be getting 3 more points. Yes or no?
Yes.
So how many total? It will be 12. Yes or no? So for tetrahedron, what is the number of truncated what is the number of truncated corners? It will be 4 into 3, 12. Yes or no? So X is 4, Y is 4, and Z is 12. Up to this you are getting?
Yes.
Everyone is clear? Yes or no? So this question is basically a combination of 3 questions. So I will deal with them one by one. So this is clear? Yes or no?
Yes, sir.
Now let us come to a cube. Let us draw a cube. Or let us draw first what you say as octahedron. Okay. So how do we draw an octahedron? We draw a square. Okay. We put a vertex on the top, put a vertex on the bottom, and then we join the sides. Okay. So when you're joining the sides, it will be something like this. Yes or no? Yes or no? This is the square octahedron. Yes or no? Now, what are the features of an octahedron? An octahedron is having how many sides? First of all, it has all the sides to be triangle.
Yeah.
Yes or no? So octahedron is like double square pyramid. Okay? Square pyramid, you take square and you put a vertex, you will get square pyramid. Yes or no? What is tetrahedron? Is like, you know, like base is triangular and then you have apex. Okay. So how many vertex you are having? 6. 6 vertexes you are having. How many corners? How many what is this? Sides you are having? 12 sides. Yes or no? 4 on the top, 4 on the bottom, and 4 in the plane. Yes or no? Are you getting it?
Yes.
And how many faces it is having? Can you tell me?
8 faces.
You would have 8 faces. Okay. Now you see, if you are having 8 faces, okay. Now 6 vertex is what? 6 cross sections when you are cutting it. Yes or no? And 8 faces means what? How many? What it says? 8 faces will give 8 truncated faces. Yes or no? Now see, how will I cut a vertex? Okay, so I will cut it like this, this, and this. So it will be like a square. It will be exactly like a base. Is it clear?
Yes, sir.
It will be exactly like a base. Okay, now you see, if you are cutting exactly like a base, then you'll get a square cross section. With one vertex will be giving 4 corners, 4 new corners. Yes or no? Are you getting my point? If you're
Yes,
cutting
sir.
like this, you're getting 1, 2, 3, and 4. So 4 corners for one vertex. So for 6 vertexes, how many corners you'll get? 24. Is it clear? Yes or no?
Yes.
Okay. Now they are asking number of square faces. So when square faces is basically the vertex which you are getting when you are cutting the top. These are the square faces. How many square faces? 6. Yes or no?
Yes, sir.
Now let us talk about the number of hexagonal. Now, if you see, when you're cutting it, basically each face is a triangle only. Yes or no? Each face of an octahedron is a triangle.
Yes.
And if you are cutting along the vertex, then I'm cutting like this, this, and this. So what is the resultant face? It's a hexagon only. Yes or no? So for each face, you are getting one hexagonal face after truncation. Yes or no?
Yes.
So how many faces in octahedron? 8. So how many hexagonal faces you will get? 8.
8 hexagonal.
Okay. So this is your octahedron. This is done. Yes or no? So let us, can we discuss cube?
Yes, sir.
Okay. So let us draw a cube. Now you see, cube is something like this. Okay. Now you see, through one corner, how many lines are passing? 3? Yes or no? If I'm cutting, it would be like this only. Getting your point. If you're
Yes,
cutting
sir.
a corner of a cube, you'll get a triangular face again.
Yes.
Okay. So for the cube, okay, if you are one vertex will be giving one triangular face. Okay. So total triangles will be how much? 8? Yes or no?
Yes.
Are you getting a point? Okay. Now, for each truncated vertex, how many corners you are getting? 3. One vertex, when you are truncating, you are getting 3 corners out of triangle. Yes or no? So if you multiply it for the 8 vertex, how many corners will be getting? 24
24.
corners. Is it clear? Yes or no? This
Yes,
is
sir.
the last part of the question. You see, when you're truncating, basically you are cutting along a square, right or no? Cutting it like this. Yes or no? If you join it, you'll get an octagon. The truncated face is an octagon. So how many truncated faces are there? Equal to original number of faces?
6
It will be
faces.
8. Sorry, 6. Yeah. So from this you can establish 6. Now you put into the formula, you'll get the answer. Can you do
Yes,
it?
sir.
Okay. Rest of the things are maths only. So I don't know how many of you got the reference of Chacha Chaudhary and Sabu. Do you people know Chacha Chaudhary, Sabu?
What's that?
Do you know Chacha Chaudhary and Sabu?
No.
Anyone? No. Okay, so these are actually comic characters, you know. of our era, it's like 15 years before you. So that's why you people might not be knowing it, because I don't think a lot of your generation people are reading comics. Okay, but so it is like that he is a very, intelligent guy. So that is why this intelligent type of question. It's not an intelligent question, it's a lengthy question, right? Yes or
Yes.
no?
Yes, sir.
Okay, so I think everyone is clear with this.
Yes.
Yeah.
Yes,
That's
sir.
why I kept it for the last. Okay, so I think the whole paper discussion is done. Is there any point which you want me to discuss in this whole paper? That now is the time for those who joined late. So if there is no such thing, then can we finish this paper discussion?
Yes.
Yes, sir.
Okay,
Yes, sir.
so I am stopping the recording now. Okay.